This intermediate Python project is a simple memory card game using Tkinter. W and H are the number of cards in the X and Y directions, so W times H is the total number of cards, and that number divided by 2 is the total number of pairs of cards. We use double slash, or the floor division operation, because it produces an integer rather than a floating point number, and we need an integer to pass to the range function. The resulting range object is passed to the list function to create a list, which is then repeated with the times 2 operation. Now we have a list of length L where every item is repeated. We shuffle the list by repeatedly picking 2 indexes and swapping their respective values. The number of times we do this is arbitrary, in this case the same as the number of cards we have. The state of the board will be kept by a dictionary whose keys are tuples, that is, in this case, pairs of numbers which represent the X and Y location of that space on the board. The values will be widgets, which will also hold the card value, as we'll see in a minute. The clicked variable keeps track of which cards you've overturned. Once you've overturned 2, the reset function hides them. The configure method will update a widget's properties, such as here, the text on a button. We can check to see if both cards are overturned with the line if none not in clicked. If clicked sub 0 is none, then no cards are overturned. And if clicked sub 1 is none, then 1 card is overturned. This is all inside the button click function, which will be attached to all of the card buttons. Underneath that function, which contains most of the game logic, we create the root Tkinter object, which is our window. Next, we create an iterator from the cards list. Nested for loops are used to set up the board. The partial function is used to create a version of button click with the arguments x, y bound to it. The button widget is then created with the appropriate command callback and placed into the window using the grid method. The next card value is then retrieved from the card iterator and stored in a custom property of the widget I called val. Finally, a reference to the button is stored in the board dictionary using the tuple xy, which holds the values of the position of that button.